Good day everyone. Today I'll be presenting my Python program about a double linked list, a type of data structures that allows us to store and connect data in both directions. In this program, I create two main classes. It is node and double linked list. The node class represents a single element or length in the list. Each node stores a value and has two connections, are pointing to the next node and another pointing to the previous node. Then the double linked list class manages these nodes. It keeps track of the head, the first node, the tail, the last node, and the size of the list. I also include several functions. It is unshift, which adds a new value at the front of the list. Then next pop, which removes a value from the end. Then shift, which removes a value from the front. And last is str function, which displays the list nicely using arrows to show the lengths between nodes. So this code shows a double linked list efficient handles data by allowing insertions and deletions from both ends, something that regular lists don't do as easily. And now let's proceed to my code. So class node, this defines a blueprint called node. Think of it as the recipe for a single item or one box that will live inside a linked list. Then def and it or self value. This is the constructor. It runs automatically when you create a new node. Self is the new node being created. Value is the data you want to store in the node. So self.value is equal to value stores whatever you passed in as the node's content. Example, node is equal to 5. The node's value becomes 5. The next self.next equals none. Adds a next attribute and set is to none for now. Next is intended to point to the node that comes after this one in a list. None means there isn't a next node. The next self.verb is equal to none. Adds a verb attribute and set it to none. Verb is intended to point to the node that comes before this one. Having both next and verb is what makes this node suitable for a doubly linked list. Next is class double linked list. This declares a new blueprint or a class named doubly linked list. It's the recipe for the whole list or the object that will hold and manage many nodes. So next, def and self. This is the constructor for double linked list. It runs automatically when you create a new list with double linked list. Self refers to the new list object being created. The next self.head is equal to none creates an attribute head on the new list and set it to none, meaning there is currently no first node. The starts empty. Later, when you add nodes, head will point to the first node in the list. Next is tell that self.tail is equal to none, creates an attribute tail and set it to none, meaning there is currently no last node for an empty list. Both head and tail are none. When you add nodes, tail will point to the last node, making operations at the end fast. Self.size is equal to 0 creates a size attribute and initialize it to 0, meaning there are 0 nodes in the list right now. Keeping size updated lets you get the number of elements in 0 or 1 time without walking the list. So next is def is the art self. This defines a special method that Python calls whenever it needs a string representation of the object. For example, when you print it. So next values. Create an empty Python list called values. We'll fill this with a textual version of each node's value. Next is current is equal to self.head. Start a pointer named current at the beginning of the list or the head. Current will walk through the list node by node. Next is while current loop as long as current is not none. In human terms, while there is another carriage in the train, keep going. This value that append is the current that value. Take, take the data inside the current node or current that value, converts it to text with str, and add that text to the value list. Converting to str ensures non-string values or numbers or object becomes printable. Next is current is equal to current dot next. Move the current pointer to the next node in the list. This advances the loops so we eventually visit every node and then stop when current becomes none. So return join values. Take all the text spaces and values and join them together in one string with greater than less than between each item. Example result is 2 greater than minus less than 2 then 1. 1. If the list is empty, values is empty. Joins return an empty string. So so now let's proceed to def pop solve. So so what this method does? So it removes the last item from the double length list or the tail, return its value and keeps the list pointers and size correct. So next line is if not self that tail check. So it check whether the list is empty and if tail is none, there's nothing to remove. Then return none. If the list is empty, the method returns none right away. Or in human terms, there's nothing to pop, return nothing. So next is if self that head is equal self that tail. It checks whether the list has exactly one node. If head and tail point to the same node, that that's the case. So next is value is equal to self that head that value. So this line save the value stored in the single node so we can return it later. And next line self that head is equal to none and self that tail is equal to none. This line removes the only node by setting both head and tail to none, or and the list becomes empty after this. So next is else. When the list has two or more nodes, we handled it. I mean, it handles the normal multi-node case here. The next line value is equal to self that tail that value. This line save the value of the current tail or the item will remove. Next line, self that tail is equal to self that tail that priv. This line move the tail pointer one node left. The previous node becomes the new tail. Then next, self that tail that next is equal to none. So this disconnect the old tail by making the new tails next point to none. This breaks the forward line to the removed node. The next line solve that size is negative equal to 1, not equal to 1. Decrease the stored size count because a node was removed. Since we returned earlier, for the empty case, this always runs only when a node has actually removed. So next return value give give back the value of the node that has removed. Now let's proceed to def chef self. So chef removes the first item or the head from the double length list, returns its values and updates the list so everything stay consistent. And if not self that head, this line check if the list is empty. If head is none, there is nothing to remove. Then return none. This this line if the list is empty, return none immediately. Then f solve that head is equal solve that tail. This line check if the list has exactly one node. When head and tail point to the same node, that's the case. The next value is equal to solve that head that value. So this line save the value stored in that single node so we can return it afterwards. Next, solve that head is equal to none and solve that tail is equal to none. This line removes the only node by clearing both head and tail. This list becomes empty. Next is else or list has two or more nodes. This line handles the normal case where there is a first node and at least one or more after it. The next is value is equal to solve that head that value. This line save the value of the current head or the item will remove and return. Next is solve that head is equal to solve that head that next. This line move the head pointer forward to the second node. That node becomes the new head. Then solve that head that Fred is equal to none. This line disconnects the new head from the removed node by clearing its Fred. Now, nothing points backward to the old head. Then solve that size is equal to 1. Decrement the size counter because a node was removed. Then return value. Ret- return the saved value of the node that was removed. And now let's proceed to def and shift, solve, and value. So this creates a new node with value and insert it at the front of the double linked list or making it the new head and updates the list pointers and size. So node is equal to node value. So this line builds a fresh node that holds the data you passed in, and this at this moment the new nodes next and fib are none. Next is I and if not solve that head, this line check wherever the list is empty. If head is none, there are no nodes yet. Next is solve that head is equal to node and solve that tail is equals to node or empty list case. This line, when the list is empty, the new node becomes both and first at the last element or visual. So next is else or non-empty list case. So this line, if there's already at least one node, will insert the new node before the current head. Next is node that next is equal to self that head. This line link the new node forward to the current first node. Now, now the new node points to the old head. Next, then solve that head that verb is equal to node. This line link the old head back to the new node. This sets the backward pointer on the old head so the double length remains consistent. And solve that head is equal to node. This line make the new node the official head of the list. It's now the first element. Then solve that size positive equals 1. Increment the store count of nodes because we added 1. So last code, DLL is equal to double linked list. So this line creates an empty double linked list. Then DLL dot unshift 1. So add 1 to the front. So a new node 1 is created. Because the last is empty, this node becomes both head and tail. Next is DLL that unshift 2 or add 2 to the front, creates node 2 and insert it before the current head. Next is DLL that unshift 3, add 3 to the front. This creates nodes 3 and insert it before the current head. Next is print DLL or display the list. HDR works from head to tail collecting values in order. The next print DLL that pop remove last element and print it. Pop removes the tail node or the last carriage. Current tail is 1. The next is print DLL or show the current list. So next is print DLL that shift remove first element and print it. So shift removes the head node, the first carriage. Current head is 3. Then next is print DLL or the final state printed. So the and this is the final output.